Okay, I want to do an interference example. Let's just do a simple one. If the speed of sound is 300 meters per second and I play a middle C or a 256 hertz tone, so a pure tone, from two speakers, how much farther from one source, from one speaker, should I be relative to the other so that I don't hear anything, so that I get completely destructive interference? So I think that you could probably think about how to do that, and I would urge you to do that before I do. You can always pause the video and think about it, but I'll go ahead and do it. So let's say, so I'm just showing this picture is supposed to be me with big ears, not eyes on the side of my head, and two speakers with sound coming out in all directions. So let's just follow the sound from speaker 1 to my ear, and then speaker 2 to my ear, and say that speaker 1, the sound travels a distance d1, speaker 2, the sound travels a distance d2. I know I drew it so they look kind of equidistant, but they're not. Or I can move up and down. I can move wherever I want. I can move up and down and in or out. And the question is how much farther from one than the other should I be so that I don't hear anything? Well, I should be farther from one than the other. Whoops, not delta D, but delta D should be a single wavelength, or not a single wavelength, a single half wavelength, a 3/2 wavelength, a 5/2 wavelength, etc. So we can answer any of those things, but let's just do the simplest one. So say, well, we need to be half a wavelength farther from one than the other. So what is the wavelength of sound? Well, we do need to know a little bit about waves, and I'm hoping you already knew that the relationship between speed of a wave, frequency of the wave, and the wavelength of a wave, right? Those three things have a relationship which is C equals F lambda. The speed of a wave is equal to the frequency of the wave times the wavelength of the wave. And that's simply speed equals distance over time, because frequency is just 1 over the period, and wavelength is distance for a period. So this is distance for a period over time for a period, and so it's the speed of the wave. So therefore, the wavelength of the wave is C over F. And in this case, the wavelength of the wave is indeed the speed of the wave, 300 meters per second. And C in this case is just the speed of any wave, not light wave. In this case, 300 meters per second. So we've got 300 meters per second over the frequency, which is 256 hertz. A hertz is 1 over seconds. So that we get about 1 meter. It's not quite 1 meter. It's exactly 1.17 meters. So the wavelength of the sound wave, it's not a small distance, it's 1.17 meters. So in order for me to be at a place of constructive interference, I should be at 1/2 of that distance farther from one than the other. Or any of the other things, but in this case I'm just doing the lambda over 2. So therefore, delta D is equal to 1.17 meters over 2, which is 0.59 meters farther from one speaker than the other. So I need to stand somewhere, and there's many places where that's true, right? But I need to be 0.59 meters farther from one speaker than the other. And of course, I can also be 1.17 plus 0. I can be 1.76 meters farther from one than the other. Do you see that? Do you see why it's 1.76? Because it's 3/2 lambda. And that will give me a position of destructive interference.